Hello, this will be a demonstration of proposition 22 from book 7 of Euclid's Elements, which says that the least numbers of those which have the same ratio with them are prime to one another. So this is clearly the converse of the previous proposition 7.21. What we're instead given is that the two numbers a and b are the least of those which have that ratio a to b. What we're going to prove is that the numbers a and b are prime to each other. They are co-prime. For if they are not co-prime, then some number has to be a common measure to them. We're just going to say that this number is c. And so we're going to have our number c measure both a and b. Of course, not necessarily the same number of times, but we're just going to have c be a common measure between a and b. Next, what we're going to do is we're going to create two numbers d and e such that the unit f, our unit f, measures the number d the same number of times that the number c measures the number a. And likewise, we're going to make the number e such that the unit f measures the number e the same number of times that the number c measures the number b. Now, because the number c measures the number a the same number of times that our unit f measures the number d, we had made the number d such that it satisfies that in our second step. It then, of course, follows from our definition multiplication that the number c times the number d is equal to the number a. What obviously follows from this as well is that our number d is less than our number a. Now, likewise, because the number c measures the number b the same number of times that our unit f measures the number e, again, by definition 7.15, the definition multiplication, c times e equals b, and what follows from that is that e is less than b. Now, c times d being equal to a, and c times e being equal to b, we have one number multiplying two numbers, making some other numbers, which means that the numbers which are multiplied have to each other the same ratio that the products have to each other. That is proposition 7.17. And so because c times d has made a and c times e has made b, we can then say that the number d has to the number e the same ratio that a has to b. Now, because we were given that the number a and the number b are the least numbers which have that same ratio, the number d has to be greater than the number a, and the number e has to be less than the number b. But we had established in our third step, for example, that d has to be less than a. And so we see that d has to both be greater than and less than a. This is impossible. This is absurd. And so we can safely say that a and b are in fact that they do not have a common measure, which means they are prime to each other. So a is prime to b, and this is precisely what we set out to prove, which means we are done with the proposition, therefore, etc., q, e, d. This gives us, of course, another way to check if two numbers are prime to each other. It's not as useful as the proposition before this, 7.21, but you will see it every now and again. What this is going to look like in a particular example is that if we say the ratio of 5 to 7 is in simplest terms, 5 and 7 are the least numbers which have this particular ratio, then what follows is that 5 is prime to 7. They are measured together only by a unit. They have no other common measure. So yeah, that's all I've got to say about this proposition. So I'll end the video here and move on to 7.23.